Mr. Harridan here. We're going to go over the Bohr's atom today here. Okay, remember what Bohr said in the last chapter. He said that electrons were in energy levels, which are very true. Okay, but he came up with the planetary model, which is not true. Okay, so we're going to focus on the electrons in energy level part right now. Okay, the electron cloud is made up of energy levels, which are like rungs of a ladder, but they are not evenly spaced. Okay, so here's an example here. This is going to be n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5. Okay, those are going to be our principal quantum numbers here, but you can see that the rungs are not even here. Okay, so they are not evenly spaced. I forgot the word evenly in here. Okay, they are not evenly spaced. The amount of energy possessed by the electron is determined by the energy level. The higher the energy level, the more energy that electron has. The lower the energy level, the less energy that electron has. Okay? Levels further from the nucleus represent higher energy. Electrons like to hang out where they are the most stable, which is called their ground state. Okay? Everybody starts off on their ground state. Everybody starts off on the ground, and then you can move up, right? By going upstairs and ladders and all that fun stuff, right? Everybody loves stairs. I love stairs. Okay. The exact energy they possessed is equal to electrons home. All electrons have their own ground state, level 1, level 2, level 8, whatever. Okay. When electrons gain a quanta is the amount of energy, okay, through heat or electricity, electrons will jump up, jump up, jump down, jump up when they gain energy through a process called excitation. Because if you gain energy, you get excited. I get very excited if I gain energy. Okay. The excited state is very temporarily. Not everybody can be excited all the time, because if everyone was excited all the time, then it would be like this, but eventually you have to calm down. Electrons are the same way. Okay. Electrons can't stay in this excited state forever, just like Mr. Harridan. He has to be in the relaxation state. Relax. Okay. So when you lose energy, you relax. When you gain energy, you get excited. The larger the fall, the larger the energy of light released. Okay, and then you see different colors based off of the amount of energy the light that's released. Sometimes it's in the ultraviolet range or visible range. You can only see what's in the visible range, right? You can't see ultraviolet or gamma or all those. But the energy determines the wavelength you see. So in this process here, if electrons gain energy, this process is called excitation. Okay? It is also called absorption. You are absorbing energy. So if you're going from level 1 to level 3, you are gaining energy. Electrons lose energy through a process called relaxation. Okay? Which is also called emission. Okay, so once we get up to the ground state, the electron comes back down to the gets excited, and then comes back down to the ground state. Usually what happens here in the relaxation part is light is released. Sometimes it's visible, sometimes it's not. And depending on how big this energy jump is, because for every electron, these rungs are at different places. That's another thing. The electrons are always on the energy levels, okay? So it goes from 1 to 4. It doesn't like go slow like that. No, it just jumps. It goes from here to there. Like quantum jump. Like that. Okay. And then when it comes back down, it goes back down. Like that. You know, like teleportation or something like that. Okay. I think I'm done with this video. You guys are champions. Yeah. Okay. The legend is out.